evaluate, we got a definite integral 1 over square root of 25 plus t squared dt. So whenever we got of this form, like square root of some number is squared plus x squared, the only way to get rid of this square root is by making a good substitution. Okay, the u sub does not work because the derivative of inside is 2t. We don't have t. I mean, we can produce a number 2, but there is no t on the top. So trig sub. So when we have this form, then that x must be a tangent theta. Okay, that way we can get rid of this square root. So here is t squared, so instead of x, so let me write t here. Okay, so we start with this one, and a happens to be 25, so this is 5. Okay, so let t equals 5, let t be 5 tangent theta. Okay, then let's find the derivative both sides, dt over d theta, and I'm going to write d theta on the other side. Derivative of tangent is secant square. Okay, and let's work on this one. 25 plus t square is square root of 25 plus t square is 5 tangent theta squared. That means 25 tangent square theta. So inside radical sign, we can factor 25 out from both terms. That's 1 plus tangent square theta. Let's take the square root of 25, that's 5, and 1 plus tangent square is secant square. Okay, that's the formula. 1 plus tangent square is secant square. Okay, let me write one extra step then. 25, this is secant square theta. So square root of 25 is 5 secant theta. Okay, so this one is also simplifies, and there is 1, nothing, dt is found here, just finding the derivative. And limits, we can wait until last minute, or we can change the limits in terms of new variable theta. When 0 and 5 are for t, but we are converting this definite integral in terms of a new variable theta. So let's convert these limits as well. So t equals 0, right? Let me put it this way. When t equals 0, so we need to use the assumption here, whatever we got in this case. From there we can convert, we can find theta. So t equals 0 means 0 equals 5 tangent theta. Okay, we are trying to get theta. So divide by 5, 0 equals tangent theta. Now we need to find angle theta, tangent of which angle equals 0. Oh, that angle is 0. Tangent of 0 is 0. In the same way, t is 5. Upper limit is 5. Let's see what happens. From assumption, 5 equals 5 tangent theta. Now divide by 5, 1 equals tangent theta. Tangent of which angle is 1? I mean the first angle, that's the 45 degrees. Tangent of pi over 4 is 1. So we don't go for theta, we go for radians. So tangent pi over 4 is 1. So this is pi over 4. Okay. Then the integral, now let's convert everything. Okay. Here these limits are 0 to 5. Now 0 means 0, 5 means pi over 4. So 0 to pi over 4. On the top dt, that's the derivative of our assumption, 5 secant square theta d theta. On the bottom, square root of 25 plus t squared, we worked out here. Okay, that's 5 secant theta. Okay, just here, 5 secant theta. Now we can simplify. Okay, let's simplify. Let me erase this line here. Then we get 5 cancelled, secant square and secant cancel. So then this integral is pretty much now, let me scroll down here. So what is left over? Looks like a lot of things cancel. 0 to pi over 4, 5 cancel, secant square secant. So one copy of secant left on the top in d theta. Now we need to find antiderivative of secant theta. So there is a formula for that one. Antiderivative of secant x is natural log of absolute value of secant plus tangent plus c, but we are in definite integral case. Okay, so using this rule, so this is now natural log of absolute secant theta plus tangent theta, and the derivative of secant is this, and we need to evaluate from 0 to pi over 4. Okay, now let's do it. So this one, upper limit, replace theta by pi over 4 and replace theta by 0. So upper limit, natural log of absolute value secant pi over 4. So what is the value of secant pi over 4? We know that cosine pi over 4, that's cosine 45, is root 2 over 2. Then secant would be just the reciprocal. Secant pi over 4 is just the reciprocal, 2 over root 2. Or we can simplify this one, because 2 is root 2 times root 2 over root 2. Cancel, so basically just root 2. Or you may leave 2 over root 2 as well. So natural log of secant pi over 4 is root 2 plus tangent pi over 4. Okay, that's what we saw earlier. Tangent pi over 4, tangent 45 is 1. That's the upper limit. Minus, let's replace theta by 0. Natural log of secant 0. Okay, that is again secant 0 means reciprocal of cosine 0, right? Cosine 0 is 1. That means secant 0 is reciprocal of 1, which is also 1. So secant 0 is 1 plus tangent of 0 is 0. Okay, root 2 plus 1, these are positive numbers, so we don't need absolute value. You can write, but this one is not really needed. Root 2 plus 1, let me put 1 plus root 2. Okay, these are unlike terms, don't combine though. Minus natural log of 1 plus 0 is just 1. And we know the value of natural log of 1. This is 0. So the final answer is basically natural log of 1 plus root 2. Okay, this will be a decimal number, but we just leave there.